Okay, so this is going to be the last video of Unit 1, and this video is talking about relative motion. Okay, so when we do problems with relative motion, basically what we're talking about is how does one object appear to be moving relative to another perspective. Now, when you see that term relative to, okay, you can basically think of that as seen from. Okay, so for example, let's say you're driving in your car and you're going 55 miles per hour north. Okay, and let's say you look at the window, you're driving in your car, you look at the window and you see trees. Okay, and if you're looking at the trees, it looks like the trees are passing you by, right? Because you're driving past them in the car. Now, of course, the trees are not actually moving, but relative to the car, it kind of looks like they're moving backwards, right? So if I'm driving 55 miles per hour north, relative to my car, here, relative to you inside the car, the velocity of the trees would be 55 miles per hour south, because it looks as though, from your perspective, from your point of view, that the trees are going 55 miles per hour south, because it looks like they're going backwards. Now, of course, relative to the side of the road, the velocity of the trees would be 0, because the trees are not actually moving. Okay, and so if you're just standing off to the side of the road watching the trees, they're not moving, you would say the relative velocity would be 0, but the same trees, if you're going 55 miles per hour north, the relative velocity would be 55 miles per hour south. Okay, so something can look different from two different points of view, depending on where you're doing your measurements from. Now, let's say you're not in the car. Let's say you've climbed up one of the trees and you watch this car go by at 55 miles per hour north. Then what you could say is that relative to the trees, that means relative to you, the velocity of the car is 55 miles per hour north. So in other words, the person on top of the tree sees the car going 55 miles per hour north. The person in the car looking back at the trees sees the tree going south at 55 miles per hour. Okay, and if that's a little confusing, then I get that. Relative motion questions can be tricky because they kind of require some visualization. They require you to use your imagination. I would recommend that if you're a visual person, drawing a picture might sometimes be helpful. But we're going to do some examples, and so hopefully you get a feel for how to solve relative motion problems. Okay, and again, we're not going to be doing any complicated math, usually just basic adding and subtracting. Okay, but make sure you understand that relative to means as seen from that perspective. Okay, so let's start with example 0.5. Okay, so example 0.5 says as you're driving north along the highway in a truck going 55 miles per hour, a car drives up beside you, also driving 55 miles per hour. And just to be clear, I'm going to say in the same direction. Okay, so this car is also going 55 miles per hour in the same direction. In other words, the car has matched the velocity of the truck. Okay, in fact, if you stuck your hand out the truck, you could high-five the driver of the car. Now, what would the velocity of the car be relative to the truck? So in other words, let's say you look at your window, the car is going the same speed as your truck. Okay, imagine if you couldn't see the background behind them. Would you be able to tell that the car was moving? No, I don't think so. In other words, the car is not passing you and it's not going behind you. It's staying steady right beside you. Okay, it's going 55 miles per hour. You're going 55 miles per hour. So I would say that the velocity of the car relative to the truck would be 0 miles per hour. Because from the perspective of the truck, it appears like the car is not moving. Okay, because you've matched speed. Now, let's say if the car speeds up a little bit and starts to pass you, then that would be different. Okay, so just for fun, the answer to this question is 0 miles per hour. But just for fun, let's say the car sped up. And let's say you're going 55 miles per hour, and the car is now going 60 miles per hour. Okay, now relative to the truck, do you see the car going 55 miles, or do you see the car going 60 miles per hour? No. Okay, it's passing you, but it's not passing you that quickly. So I would say in this situation, if you're in the truck, you're going 55, the car is going 60, I would say that the velocity relative to the truck would be 5 miles per hour. Okay, and again, the way I get that is because even though the car is going 60, you're going 55, and so it's from your perspective, it only looks like it's going a little bit faster than you are. Okay, so it's going to pass you, but it's not like it's going to zoom past you because they're both going pretty quickly. Okay, so I would say the velocity of the car relative to the truck is 5 miles per hour north. Okay, so this is relative to the truck. Now, what if you're in the car and you look at the window? Now I'm in the car, I'm going 60, the truck next to me is going 55. Okay, we're both going north along the highway. Now, I'm in the car, I look out my window, and what do I see? I see the truck going backwards because I'm passing the truck, right? Because now I'm in the car, I'm going faster than the truck. It looks to me like the truck is going backwards. I would say that relative to the car, the truck is going 5 miles per hour south. Okay, now is the truck really going 5 miles per hour south? No, of course, because the truck is still going 55 miles per hour north. Okay, but relative to me inside the car, it looks like the truck is going backwards. Okay, so that is example 0.5. Pause it there if you need to look at that. And now we're just going to do a few more examples with relative motion, and hopefully you get the hang of this. Okay, so relative motion example 1. It says this train is headed from from Grand Central Station to Central Park North at a speed of 12 meters per second. You decide to walk to the back of the car where your friend is seated at a pace of 2 meters per second. What would your speed be relative to the ground? Okay, so I'm going to draw a picture, okay, just because I'm a visual person. So here is the train car, and let's say the train is going forward at 12 meters per second. And I am going to walk to the back of the car at 2 meters per second. So here's me, and I'm going to walk back at 2 meters per second. Okay, so when it says what would your speed be relative to the ground, that means if you were outside the train car, just off to the side, looking at the situation, how fast does it look like you're moving? Well, you're fighting against the motion of the car, right? The car is going 12 meters per second this way. You're going towards the back of the car. So I would say relative to the ground, your relative speed would be 12 minus 2, which is 10 meters per second. Okay. In other words, because you're fighting against the motion of the car, it looks like you're moving slower than you actually are. Okay. Now, if I was walking towards the front of the car instead of towards the back, then that would be different because then these two arrows would be going the same direction and they would add together instead of subtracting. Okay, so that is relative motion example 1. Let's take a look at a few more examples. Okay, relative motion example 2. It says you are staying on a train platform watching the trains go by. What would you say person A's velocity is relative to you? Okay, so now we're off to the side looking at the situation that's happening inside the train car. Okay, person A's velocity relative to me, I see that the train is going 6 meters per second to the right, plus person A is also moving to the right at 1 meter per second. Okay, so I would say person A's velocity is going to be 6 meters per second plus 1 meter per second to give me 7 meters per second. Okay, relative to me outside the train. Now, what if I was inside the train? Okay, what if I was standing next to person A inside the train? Well, then their relative velocity would be 1 meter per second. Because then from my perspective inside the train car, I only see them going to 1 meter per second because the 6 meters per second is happening outside, okay, because the whole train car is moving. Now the second question says, what would you say person B's velocity is relative to you? Okay, so that's the same type of question. I see that the blue car is going to the right at 4 meters per second, but now person B is walking backwards towards the back of the car in the negative direction. Okay, so I think of that as like 4 plus negative 1, kind of like in the last example where you're subtracting instead of adding. Okay, and that would be 3 meters per second. Alright, so that is relative motion example 2. Okay, so again, pause it there if you need to look at that some more. Okay, I'm just going to do one more example with relative motion. Okay, so car number 1 travels north at 30 miles per hour, and I'm going to draw a picture just so I can visualize this. So here's car number 1, and it's going north at 30 miles per hour. And it says car number 2 travels in the same direction at 40 miles per hour. So here's car 2, same direction, 40 miles per hour. What is car number 1's velocity include direction relative to car number 2? Okay, remember relative means as seen from. So now for this first question, I am inside car number 2 and I'm looking over at car number 1. Well, if I'm in car number 2, I'm going faster. That means I look out and I see car number 1 going backwards, right? Because I'm passing car number 1 because I'm going faster. Okay, so from my perspective in car number 2, I would say that the relative velocity is going to be south. Okay, that's the direction. And then the amount, if I'm going 40 and they're going 30, that means the relative speed is going to be 10 miles per hour. Okay, so car number 1's velocity relative to car number 2 is going to be 10 miles per hour south, because as seen from car number 2, car number 1, which is going slower, is traveling in the negative direction south. Now the second question says, what is car number 2's velocity relative to, that means as seen from, car number 1? Okay, so if I'm now in car number 1, car number 2 is going faster than me. I see car number 2 passing me, okay, but it doesn't look like they're going that fast from my perspective. So that would be 10 miles per hour. And I see car number 2 going north because they're passing me, and so that would be 10 miles per hour north. Okay. So again, if you're in the faster car, it looks like the other car is going backwards. If you're in the slower car, it looks like the other car is going forwards. Okay, at the same amount of speed, but just in the different direction. Okay, so that is example number 3 with relative motion. And again, these problems are not super complicated, but you have to visualize and you have to use your imagination on some of these. Okay, so as always, please let me know if you have any questions, especially before your unit test, which is going to be during the next class. Please let me know if you have any questions, and I will see you guys in the next video.